The Kitty Dry Chemical System is a fixed dry chemical system consisting of a supply of dry chemical stored in a multiple cylinder and valve assembly. Each cylinder is pressure activated by a system valve actuator. The system can be actuated either automatically and/or manually using mechanical, electrical, or pressure actuation devices. Upon actuation, the dry chemical is discharged through agent distribution piping and specially designed nozzles positioned throughout the protected area. Activation of any heat detector or electronic release station will cause the following to occur. The alarm detector's red status light will illuminate. The device's custom address will be displayed on the control panel's LCD display located outside the room. The horn strobe will operate. The HVAC systems in the building will shut down. The 10-second programmed pre-discharge time delay will begin. Upon the expiration of the 10-second delay, a discharge condition will be enunciated on the control panel. The dry chemical suppression system will discharge. If a trouble or supervisory condition is enunciated on the control panel, the Sparks Fire Department will be notified through the monitoring company. Disabling the system using the key switch in the AFFF-AR tank room or disabling any addressable device, a trouble and supervisory condition will be enunciated. Each individual hazard room is provided with a dedicated air handling ground-mounted unit. Air is withdrawn from the space served by the same unit and exhausted at a rate of 6 air changes per hour. Air is completely replaced in the affected space every 10 minutes. All air handling equipment will automatically be de-energized in the event of a fire. 14 smoke hatch openings are available for evacuation of smoke and fumes from the main warehouse area. The activation of these spring-activated hatches are accomplished manually from a separate set of controls next to the fire alarm control panel. The basis for design for the fire alarm system includes compliance with the 2006 International Fire Code and the 2006 International Building Code. The system provides manual and automatic operation with on-site audio and visual alarms to indicate a fire event within the building. The fire alarm system includes manual pull stations at exit-discharge locations. Mechanical system monitoring includes duct-mounted smoke detectors to monitor supply-side ductwork of all HVAC air handlers moving more than 2,000 CFM. The duct smoke detectors are provided with remote test indicator and reset buttons. These are located in corridor areas outside the space served by the associated unit and prominently identified. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. The building fire alarm zoning is geographic in nature and essentially follows the building areas defined by this drawing shown graphically on a Lexan Fire Alarm Directory located in the Fire Alarm Control Room and the AFFF-AR Tank Storage Room. The system includes a remote annunciator with test, system silence, and system reset switches behind a locked cover. The building is equipped with strobe and horn strobe notification appliances. Beacons are located outside of exterior and interior doors to each storage area in order to indicate which space is in alarm. 2 beacons are mounted over the fire alarm control room where first responders can easily see them on approach to the scene. A red beacon indicates the alarm is in the flammable solids water reactive storage room and the dry chemical suppression system has discharged. An amber beacon indicates the alarm is in the flammable liquids area and that the AFFF-AR foam system has been discharged. The OSID smoke detector provides early warning of fire by measuring the amount of smoke entering invisible beams of light projected over the main warehouse area near the roof deck. New smoke detection technologies provide superior immunity to false alarms caused by dust and solid objects that may interfere with the beams. Innovations in optical imaging and signal processing enable the imager unit to locate the emitter unit without the need for precise alignment and compensate for natural building shifts. The actual sequence of events in an alarm condition depends on where the event takes place. If the alarm conditions is in the flammable liquid storage area, it will activate the AFFF-AR system. The likely sequence of events would be as follows. Failure of the heat sensing element will result in immediate system operation in the affected area. The AFFF-AR system will activate, resulting in the discharge of AFFF-AR solution through all the open foam water heads in the flammable liquids storage room. The associated zone shall be enunciated on the fire alarm control panel. Horn strobe devices shall operate throughout the facility. HVAC units serving the entire building shall be de-energized and fire and smoke dampers shall close. The magnetic door holder and other similar devices shall operate, resulting in door closure of all hazard room doors through the fire alarm control panel. The blowable spill bars at each interior hazard room door will close. The fire alarm sequence will be initiated. Ceiling or duct-mounted smoke detectors will provide a signal along with the address of the associated device and its location to the fire alarm system, which in turn will trigger the standard response that includes activation of horn strobe devices throughout the facility, air handling units AC1, AC2, AC3, AC5, AC7, AC8, and AC10, the 2 existing Cambridge air makeup units for the existing warehouse, and the 3 existing HVAC units for the office space will also be signaled to shut down. Upon a signal from any of these devices, horn strobe notification appliances located throughout the building will also activate. Fire alarm pull stations will also cause horn strobe devices to activate throughout the facility. Upon alarm, the system will provide notification to local fire protection services via an alarm monitoring company. A representative of Alfa Aesar, the general manager and/or chemical inventory manager, will be contacted via beeper. A rotating beacon will operate outside the affected space. The flammable liquids area is the only area using the AFFF-AR system. The flammable solids water reactive room uses a dry chemical suppression system. All other spaces in the building use the wet pipe sprinkler system. Failure of the heat sensing element at any sprinkler head in these areas will result in immediate sprinkler operation in the affected area. Water flow within an individual zone will initiate a fire alarm via the fire detection and alarm system. If the tamper switch at any system component is activated, or if the low water pressure switch is activated, this signal will cause a trouble condition on the fire alarm control panel, and its identification will be enunciated. The alarm sequence will be activated. Controls for the manual operation of the air handling units are located next to the fire alarm control panel in the fire alarm control room and in the AFFF-AR tank room. These provide the ability to pressurize various adjacent portions of the building in a controlled manner to mitigate the accumulation of smoke or noxious odors so that emergency response personnel may more effectively enter the building. The areas identified as Zone 11 have 14 smoke vents that can be manually opened to release smoke at those locations. The air handling units for each area have 3 modes of operation. In automatic, normal, non-emergency mode, the unit is under control from space temperature and humidity sensors and can only be changed from the system backnet control panel on any computer tied to the company network system. Automatic off. When the fire alarm is activated, all mechanical units in the building will shut down. The systems will return to normal mode when the fire alarm panel is reset. While the fire alarm is in alarm, manual operation of each unit can be done depending on the location and type of incident. Pressure control mode. The unit is energized in economizer mode, regardless of outside air temperature, with both supply and return fans energized. The unit supplies 100% outside air to the spaces served and exhausts 100% of the air returned to the unit. This mode maximizes the introduction of outside air into the space and the removal of smoke or airborne particulates. Unit heating and cooling controls are enabled to supply 75-degree Fahrenheit discharge air within the limits of the heating and cooling equipment called for. Supply air fans and return air fans run automatically depending on whether a room is to be positively or negatively pressurized. The Alfa Aesar Sparks Nevada facility has been designed and built with safety in mind. Everything from the storage containers used, the separation of materials by category, and the safety equipment installed ensure a safe storage condition. In the event of an incident at the facility, the fire suppression and alarm system will operate automatically to isolate the affected area and initiate the fire suppression system. This will give fire department personnel and first responders time to respond and take control as necessary. At Alfa Aesar, safety is the prime concern.